Next, let's practice finding exact values for multiples of 30 degrees and 60 degrees. So if I have 210 degrees, well, 210 degrees is 7 pi over 6 radians. So I know it's going to be a multiple of pi over 6. So I got 1 pi over 6, 3 pi over 6, 6 pi over 6, 7 pi over 6. Oh, it was already labeled. Which is 210 degrees. Cosine is my x value, so I have negative square root of 3 over 2 is my value for cosine. Changing colors, if I have sine of negative 60 degrees, here's my one for 60 degrees, right? This was 30 degrees. Negative sign, that means I go counterclockwise, negative 60 degrees, so that puts me here. Sine is my y value, so I have negative square root of 3 over 2. Next, for tangent of 5 pi over 3, that's going to be this right here, this point right here. So I go 1 pi over 3, 2 pi over 3, 3 pi over 3, which is just pi, 4 pi over 3. So I end up again at the same point. Tangent is my y value over my x value. So I get negative square root of 3 over 2 times 2. So I get negative square root of 3 as my exact value. Let me change colors again. If I have cosine of 8 pi over 3, right? Let's go over here. 8 pi over 3. So if I have, oh, okay. So this is like saying 6 pi over 3 plus 2 pi over 3, right? This is 2 pi. That's 360 degrees. It's one full whole rotation around our circle. And then I went another 2 pi over 3. So I end up here. So I have a cosine. That's my x value. So I have negative 1/2 as my value. So it's important to note that we can't have values greater than 2 pi or 360 degrees. So caution. A common error in trig is using a calculator in degree mode when it should be in radian mode and vice versa. So if I want to find the sine of 48 degrees, I make sure my calculator is set to degrees. And I punch that in, and I would get 0.74. If I want to find the secant of 21 degrees, well, you're going to probably see your calculator doesn't have a secant button. We talk about this more in section 5.3, but secant of theta is the same as 1 over cosine of theta. So I would plug into my calculator 1 over the cosine of 21 degrees, and that'll give me about 1.07. And if I want the tangent of pi over 14, I have to switch to radians, switch your calculator mode to radians, and that would give you about 2.3. And again, I am rounding. So for an angle theta in standard position, P equals XY, let P equals XY be on the terminal side of theta that's also on the circle x squared plus y squared equals r squared. So now our radius doesn't have to be 0. One. That's the key takeaway. Our radius doesn't have to be 1. So sine of theta, which before was y, would now be y over r. Cosine of theta, which before was x, would now be x over r. And tangent of theta, it stays the same as long as x doesn't equal 0. Cosecant now is flipped, right? Now it's r over y as long as y doesn't equal 0. Secant is r over x as long as x doesn't equal 0. And we'll do a couple examples of this in section 5.3. And cotangent of theta equals x over y as long as y doesn't equal 0. So let's go through the final example in this section before we take a look at section 5.3. So we want to find the exact values of the 6 trigonometric functions of an angle theta if 4, -3 is a point on the terminal side in standard position. So I have when x, we have some circle, and when x is 4, y is -3. So our angle is like a pretty big angle, right? Kind of looks like Pac-Man. Maybe not. So we remember that x squared plus y squared equals r squared. So if I have 4 squared plus -3 squared equals r squared, that gives me 16 plus 9 is r squared. 25 equals r squared. We take the square root of both sides to get 5 equals r, and it's going to always be the positive one because we can't have like a negative radius because it's a measure of distance. So this means sine of theta, which is now y over r, is -3/5. Cosine of theta, which is now x over r, is 4/5. Tangent of theta is still y over x, so I've got -3/4. Cosecant of theta is now r over y, so I have 5/3. Secant of theta is y, nope, slow down, r over x, which is 5/4. And cotangent of theta is unchanged, it's x over y, which would be 4/3. So that's how we would find the exact values of our trigonometric functions on a circle without radius equal to 1. So here's our unit circle, fully filled out, so you have it and can check your work. A unit circle has its center at the origin, its radius is 1 unit, and its circumference, which normally for a circle is 2 pi r, in this case is just 2 pi. And 1 revolution around the circle is our arc length 2 pi, or it's a 360-degree angle.